car of mass 900 kilograms is towing a caravan of mass 400 kilograms. The engine exerts a driving force of 2 kilonewtons, or 2000 newtons. They increase speed from 4 meters per second to 10 meters per second in a distance of 84 meters. The resistance on the car and the caravan are proportional to their masses. We want to find the tension in the tow bar. Let's first deal with the information that the system increases in speed from 4 meters per second to 10 meters per second in a distance of 84 meters. Since here we're going to have constant acceleration, since the resultant forces are constant, this is SUVAT information. So we need to collect the information together. The distance we know is 84 meters. The initial speed is 4 meters per second. The final speed is 10 meters per second. And we would like to know the acceleration. These four quantities are linked by v squared is u squared plus 2as. Substituting in, 10 squared is 4 squared plus 2 times the acceleration times 84. So 100 is equal to 16 plus 168a. This gives us 84 is equal to 168a, and therefore the acceleration of our system is 0.5 meters per second squared. We can now draw a diagram of our situation. We have a horizontal road. On it we have a car of mass 900 kilograms towing a caravan which has a mass of 400 kilograms. Here is the tow bar. We know the force driving us along is 2000 newtons. The resistance on the car and caravan are proportional to their masses. So we can say the resistance on the car is 900k and the resistance on the caravan is 400k, where k is the constant of proportionality which we will need to find. We calculated that the acceleration of this system is 0.5 meters per second squared. If we consider first as a combined object, we have a mass of 1300 kilograms, that's the car and the caravan added together, being pulled by a force of 2000 newtons against a resistance of 1300k, which is the two resistances combined. The acceleration of this system is 0.5 meters per second squared. If we use F equals ma, we have 2000, take away the 1300k, is equal to the mass, 1300, times the acceleration, which is 0.5. Rearranging, this gives 1300 K is equal to 2000 take away 1300 times 0.5. This gives us that K is 2000 take away 1300 times 0.5 divided by 1300. And this gives us that K is equal to 27 over 26 as an exact fraction. We want to find the tension in the tow bar. So if we just consider the caravan by itself, we know that it has a mass of 400 kilograms it's being pulled by the tension in the tow bar, and the resistance to motion is 400 times 27 over 26, the value we just found for K. This is accelerating at 0.5 meters per second squared. Using F equals ma, we get T take away 400 times 27 over 26, which is the resultant force acting on the caravan, is equal to the mass, which is 400, times the acceleration, which we know is 0.5. So T is going to be 200 plus the 400 times 27 over 26. Evaluating, that gives us that T is equal to 615 newtons, correct to 3 significant figures.